FastMCP 3 introduces a composable lifespan mechanism that enables server-level initialization and teardown through asynchronous context managers, ensuring resources are properly allocated and released during the server's lifecycle. This pattern leverages Python's asynccontextmanager to define legacy-compatible lifespan functions that integrate seamlessly with the framework's modern, at-lifespan, decorator system. We are about to examine how a legacy lifespan function, defined using the asynccontextmanager decorator, is integrated into a FastMCP server instance, demonstrating backward compatibility while maintaining the framework's structured initialization and cleanup workflow. From ContextLib import asynccontextmanager. From FastMCP, import FastMCP. At asynccontextmanager. Async def legacy lifespan server. Yield key, value. MCP equals FastMCP MyServer. Lifespan equals legacy lifespan. This code demonstrates FastMCP 3's backward compatibility with legacy lifespan functions using Python's asynccontextmanager. The pattern shows how existing async context managers can be seamlessly integrated with FastMCP's new lifespan system without requiring refactoring to the new at-lifespan decorator. The legacy lifespan function uses the familiar asynccontextmanager decorator to create an async context manager that yields a simple dictionary. When passed to FastMCP, this legacy function works identically to the new lifespan system, maintaining the same startup teardown behavior and context propagation. This approach is particularly valuable for incremental migration scenarios where you need to maintain existing code while adopting new FastMCP features. The trade-off here is between modernization and migration cost. While the new at-lifespan decorator provides better integration with FastMCP's composition system, supporting legacy context managers allows gradual adoption. The code shows that both approaches yield the same lifespan context that becomes accessible through CTX. Lifespan context in tools, ensuring consistent behavior regardless of which pattern you use. Let's break it down. From ContextLib import asynccontextmanager. Imports the asynccontextmanager decorator from Python's ContextLib module, which enables creating asynchronous context managers using generator functions. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for creating MCP model context protocol server instances. This class serves as the entry point for defining and configuring MCP servers in the FastMCP 3 framework. At asynccontextmanager. Imports the asynccontextmanager decorator from Python's standard library, which transforms a generator function into an asynchronous context manager for use with async with statements. Async def legacy lifespan server. Defines an asynchronous function named legacy lifespan that accepts a single parameter server. This function is designed to handle server lifecycle events, executing setup and teardown logic when the server starts and stops. The async keyword indicates it can perform non-blocking operations, and the server parameter suggests it will interact with the FastMCP server instance during these lifecycle phases. Yield key, value. Yields a dictionary with a single key-value pair where key maps to value. This is a generator expression that produces the dictionary object when iterated, typically used in Python to return data lazily or in streaming contexts. The yielded dictionary contains exactly one entry with the string key as the key and the string value as its corresponding value. MCP equals FastMCP MyServer. Lifespan equals legacy lifespan. Creates a FastMCP server instance named MyServer with a legacy lifespan configuration. The string MyServer serves as an identifier visible in MCP protocol handshakes, while the legacy lifespan parameter specifies the server's startup and shutdown behavior. This line initializes the server but doesn't start it. That would require an additional call. FastMCP3's composable lifespan mechanism bridges legacy and modern patterns through Python's asynccontextmanager, enabling seamless integration of existing async context managers with the new @lifespan decorator system. The legacy lifespan function demonstrates this backward compatibility by yielding a context dictionary that becomes accessible via CTX, lifespan context, maintaining identical startup teardown behavior regardless of whether you use the legacy decorator or the new system. This design choice prioritizes incremental migration, allowing teams to adopt FastMCP3's features without immediate refactoring while ensuring consistent resource management across the server lifecycle. The trade-off between modernization and migration cost becomes clear. While the new decorator offers tighter framework integration, supporting legacy patterns ensures a smoother transition path for existing codebases.
The decorator names the server, but the context silently replaces it with its own.